booth out here and talking about what we're up to. So why is a railroad person here? I've been the CEO of Sierra Railroad Company for 30 years now. We were the first company in the world to run on 100% biodiesel on our locomotives. We decided to start making our own fuel, and so 20 years ago we launched Sierra Energy as a way to make fuel out of waste. The FastOx technology, waste gasification, is what we ended up creating as a way to make fuel for our locomotives. So we have our gasification facility just up the road in Monterey County here at Fort Hunter Liggett in partnership with the U.S. Army. We've been operating that for quite some time, demonstrating that we can take any kind of waste, really just anything, and turn it into clean syngas and then on to final products. We're now building hydrogen-fueled locomotives. So what we're doing is we've got our first one up in West Sacramento. We've got 3 more we're building this coming year. But we're making hydrogen from waste and then running our locomotives as zero-emission locomotives from waste. I'm a poli-sci major, so I'm going to describe how the gasifier works in very simple terms. Basically, it's a counter-current fixed-bed gasifier, and it's slagging. So we create a tar-free syngas, and what we do is we put just about any waste, all those things that you show there, tires, municipal solid waste, biomass, batteries, electronic waste, construction and demolition debris, medical waste, and hazardous waste. We've demonstrated on all of that. We really don't care what you feed us, and we don't care how you mix it up, and moisture really doesn't bother us a whole lot. So you stuff it in, you heat it up, and we operate at 2,200 degrees Celsius. So that's very high, and so if you happen to be inconvenienced by PFAS, we get rid of that as well. So you put the waste in, heat it up at 2,200 degrees Celsius. How do you get there? You inject steam and oxygen, and so we're an oxygen-blown gasifier. The steam goes in actually to reduce the temperature because when you just put oxygen and carbon together, you get very high temperatures. You modulate it with this steam. You also, as an added benefit, get more hydrogen out as a result. So really cool putting that in. If there's metal in your waste, if there's inorganic solids, it melts, it pours out. And this is fundamentally a blast furnace, and so they're designed to recover that metal. So whatever metals were in your waste stream, you recover all of them. Any other inorganic solids come out as a liquid slag. It's actually really cool to watch. It looks like lava. But that goes through a water bath, and you make little rocks. Since we use a flux, we use limestone. Basically, you're putting that flux in at the same time as an additional feedstock. It actually improves the quality of the slag. That's what you're trying to do, is you're engineering the quality of your slag. There's a product many of you have probably heard of called ground granulated blast furnace slag. It's got a great acronym, GGBFS. That is actually used as a cement replacement. And so like the Bay Bridge up in San Francisco, half of it was GGBFS. So that means that your waste is 100% recycled. All of the metals are recovered. Inorganic solids turn into a slag that can be used as a cement replacement, or if you're in an area that doesn't need it, it's just road base. But that means you're able to use all of the waste. So it's true 100% recycling, and the process itself has 0 emissions. So you then create this tar-free synthesis gas. I am not going to tell this group all the cool things you can do with syngas. You all know it, and it's been very well explained. Thank you very much. But basically, we've been in business for 20 years. Over that time period, we've received over 10,000 requests from people around the world looking to deploy a gasifier. And we do a survey as we ask all these people, what is it you're doing and what is it you're after? Historically, the #1 thing people wanted was electricity. They just, can we make power and do something cool with it? The last few years, it has been predominantly hydrogen. Everybody wanted to chase hydrogen. Interestingly, in the last year, or just the last 9 months, electricity has suddenly come back in vogue around data centers. Could we take some sort of waste that we happen to have and turn it into power to run a data center? Yes, you can. So we're particularly excited about hydrogen because that's what our locomotives run on. This just talks about our gasification system. Our objective right now is we're building 100-ton per day modules. It's an arbitrary size, so we've done all our engineering around that. And that's what most of the customers we're talking to right now are in multiples of 100 as far as for what their projects that Scott and his team are working on. But the work that we've done at FHL, or Fort Hunter Liggett, in partnership with the Army, has gone very well. We've demonstrated all the different feedstocks. And so what we're doing right now is we're doing a Gen 2 system around a number of new patented improvements that we've made, which are pretty exciting to customers. So that new system will be what we'll be demonstrating down there in the coming year. And so anyways, that's what we demonstrate there at Fort Hunter Liggett. This is just sort of a project economics, just to give people some examples at 400 metric tons per day, which seems to be a really common request lately in that sort of scale. We can go smaller or larger, but that just seems to be the most common request. And it shows that based on hydrogen, electricity, or methanol, and for most folks, these are, by the way, these are specific examples. No name, but these are specific examples we're working with. What incentives, IRA or different state incentives? In Europe, they're a green methanol incentive. But as you're looking through all of these things, what's interesting is the EBITDA over basically your return. What's your profit on doing these things? It ranges from hydrogen with a 48.9% annual return, 39% electricity, 18.3% on methanol in Europe. All of these are really robust returns on garbage. I mean, nice things to take your trash and turn it into something more valuable. And so this is why we get excited about opportunities with different communities that are trying to do something better with their waste. We're awfully excited about LA County and Mesquite, by the way, simply because not only is it a great opportunity to deploy railroads and hydrogen locomotives, but this is the kind of thing, this is where counties are looking to do something better with their waste at large scale. It's a heck of an opportunity. So great hearing about it again this year. So we see this as a very interesting market, deploying FastOx technology. Power for data centers, as I mentioned, is something that's just real common that folks are interested in right now. We see hydrogen being deployed as a zero-emission alternative for fuels in the transportation industry, for the locomotives for us particularly. Green methanol is something that's coming up quite often. I mean, once you've got methanol, you can make just about anything. So methanol is a very, very high demand item, also for shipping. And so, in any case, this is just an interesting opportunity to make a good return on investment from waste. ETA, got your logo in here. We asked them last year to do a study, and these were some of the results they came out with. But we came out as the most efficient gasifier, the lowest capital cost per gigajoule of syngas versus similar capacity competing technologies in the database. So I thought that was actually very useful because there are a lot of gasification technologies floating around, and they have been for many years. But our objective is not to become some sort of mega company. Our goal is actually to license the technology to whoever needs it. We see this as an enabling technology for other companies that have got really interesting end products or processes that they're trying to do. We're just trying to give them a technology that'll make it easy for them. So that's what we've been focused on, is supporting other companies with our technology, making it available to them. This kind of thing just explains the various advantages of this technology. And because of the high temperature, it allows you to really take anything, any sort of waste stream. So it really makes things a lot easier. And we also have a very low CapEx relative to what you're accomplishing. That really comes down from the integrated gasifier polisher design of the system and the tar removal. So that means you're getting a tar-free synthesis gas coming out of the process. So in any case, by the way, in case it looks really funny me turning like this is the first time I've seen this presentation, so it's very exciting. My wife was very grumpy about not coming on the trip, so I don't think she let me see it before I came down. So in any case, taking the world's 2.2 billion tons of waste each year that we as a planet are tossing, you could make 220 million tons of hydrogen. That's our number, by the way, is roughly 10%. Of whatever waste you're putting in, about 10% of that is what you would net out in hydrogen after water-gas shift. So you could obviously meet 12% of the global Paris Agreement just by deploying one technology to take care of that waste. It also has the benefit of eliminating, methane from landfills. So there is, by producing good energy end products, you create a lot of opportunities to eliminate that methane coming out of landfills, which is one of the most, in fact, in California, our green, wonderful environmental state, #1 source of unregulated emission is landfills. California, we did that NASA flyover, and we found out that's the biggest problem in the state, and they just paper right over it in the state of California. They don't want to know. But this is where the problem is. So anyways, significant amount of CO2 reduction for each gasification system that you deploy. We compare ourselves here to other general, obviously not specific companies. We identify some out there that are in that space, although this is not a head-to-head, so to speak. But just where we see advantages, typically syngas yield is the real driver. That's where you see significant advantages of Sierra Energy over other technologies. And commercially proven is really our weakest spot, simply because we don't have, like Anchor and such, where you've got 1,000 deployments out there all over the place. So we have limited demonstration at this point, but we expect to improve on that going forward. This is our facility, as mentioned, down at Fort Hunter Liggett. The run time when it was commissioned, some of our partners in the military, California Energy Commission, and some of the other folks that have been helpful in getting this out there. And again, just talking about the partnership that we see as far as, we want to put these across the country at short line railroads. There are 550 of them. But placing these systems out there on railroads makes it so it's very rapid deployment, bring waste in by rail, converting it to hydrogen, and replacing locomotives that are running on diesel. So we see it as just sort of an easy initial model for us in working with our railroad partners nationwide. This is how it's done. This is going to be very brief because this isn't a railroad crowd, but this is how our locomotives are set up. It's all modularized, so we just put each different component in. We do as a hybrid with hydrogen and batteries with fuel cells. This is the first one. We've actually got the ribbon cutting on September 4th with a bunch of fancy politicians up in West Sacramento. In partnership with Sierra Energy. So that's it. Thank you. Appreciate it.
It's great. Thank you very much. Forgot to mention, we're actually working on a project in Imperial County, so we hope that